All right, so section 3.5, graphing techniques, AKA transformations, which we literally did every unit of Algebra 2, okay? So every unit of Algebra 2 on functions, you do transformations. Can you shift the quadratic? Can you shift the cubic? Can you shift the square root? Can you shift the exponential? It's stuff that you've already done, except instead of just having a unit on transformations, we did transformations every single unit for every single function, okay? Now this is strictly on just transformation, okay? So we're gonna go over vertical and horizontal shifts, graph functions using compressions and stretches, and graphing using reflections and the x-axis or over the x-axis or the y-axis. Okay, does this look familiar? Your H and your K? Your H and your K tells you whether you're going left, right, up, or down. If you remember me saying your X is always a liar. So even though it looks like it says H is negative, is it really negative? No, it's positive, okay? Your X is a liar. So if I have f of x plus k, that means I'm going up. If I have f of x minus k, that means I'm going down. If I have x minus h, that means I'm going to the right. And if I have x plus, my plus sign fell off. That's a plus. And if I have x plus, blah, 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 f of x plus 4, then I'm going to the left because my x is a liar. Okay, they're an x for a reason. I've never been lied to. I don't have any of those feelings. It's just a good way. I've learned that a lot of y'all are emotional. I said what I said. All right. I'm trying to get rid of these random bars that keep freezing. There we go. All right. Questions about horizontal and vertical shifts. Sounds familiar? Yeah. All right. Read the notes are on your bright space. Okay. All right. So with vertical shift, literally you are taking your y values and you're adding or subtracting that amount onto it, right? So you're changing the y values. Vertical shift affect your y. So for my people who are strong with English, is it effect or affect for when you're describing right now? Is it the A or the E? If I'm saying affect.
Like X affects Y?
That vertical shifts affects y value.
It's A.
It's A? Okay.
I think, yeah. I think yeah. A is like the action of
yeah,
B
it
is
sounds
like.
right.
Is that right?
Yeah. It's not, yeah, it's not.
Okay. This was a class collective effort. So
Hold up,
this is where we're, this is where we're coming.
Okay, so yeah, I'm right. A is the initial action, like X impacts Y instead of the word you use. A effect is like using the word impact.
Okay.
E effect is the result of.
Okay.
It's like
Yes.
cause and effect.
So we have the right L. Okay. Cool. 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 So vertical shifts affects y values. Okay. This is math class and we went too deep. So all right. So our example of how this would be graphed. So our initial function is the square root function. So we have f of x equals the square root of x. And our transformation is going to be the h of x function, which is the square root of x minus 2. Okay, so our x's are not being affected. So our x's are 0. What are my smallest square roots? 0, 4, 9, right? 16. The smallest square roots, 0, 4, 9, 16. So their values, what's the square root of 0? Oh, I forgot 1. There you go. Square root of 4, square root of 9, square root of 16, square root of 1. Sound about right? Okay. Now it's saying that minus 2. So mathematically, what you're doing for your new graph, instead of having to plug in your x values, all you're doing is transforming your y values, right? So to each y value, what am I doing? subtracting 2. So 0 minus 2 equals -2. 2 minus 2 equals 3 minus 2 equals 4 minus 2 equals 2. 1 minus 2 equals -1. No, you're using the, if I plug 0 in, what do I get? Yeah. So my transform, so it says use the graph. We use the graph of our original to obtain the graph of this one. So my new graph, my x values are still the same. So, but I'm going to 0, and then I'm going to -2. So I go to 0, -2. I'm going to go to 1, then -1. I'm going to go to 4, then 0. I'm going to go to 9, and then to 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 1. And I can't do 16 because it's not on the graph. And so this is my transform square root function. Literally describe what took place to the parent function. We vertical shift down by 2, right? Okay, how does this affect the domain and range? So the domain, was your domain affected? No, because did you even change the x values? No, we did not. Our domain was not affected. Our domain is still from 0 to infinity. Our range, however, was affected. How did our range change? Where does it start at now? -2, and then to infinity. Do we see the difference? See? All right, that's a vertical shift, graphically and algebraically. Questions, comments, concerns? Does this feel familiar?
Yes.
Okay, because I know for a fact we did it. This exact problem. We did this exact problem. Yes. So if it did not feel familiar, ugh. All right, horizontal shifts. Okay, horizontal shifts affect our x values. Okay. So and it's doing the opposite of what we think. And that's because the equation is already a positive h value. So the only way to change the operation is that it has to be a negative operation, negative number, I'm sorry. All right, so if it says x minus h, I'm heading to the right. If it says x plus h, I'm heading to the left. What that means mathematically, that means that I am adding the h value. So here I'm adding the h. So it's your x's plus the h. What's happening mathematically here? It's your x's minus the h. And again, it's because x's are letters. Okay. All right, so graphically, let's see what happens. All right. I need you to do me a favor here. This is just supposed to be an x. And this is supposed to be f, so ignore that. All right. So if we start off with our parent function here, I have 2 changes I have to make. I'm missing a column. Pretend that this is the straightest line you've ever seen. And if you remember from geometry, when you put the little tally mark, it means it's to transform. Y'all remember that? Vaguely? All right, so here we have x minus 3 squared plus 2, okay? In order to know what your original x and your original f of x is, you need to know what the parent function is. What is the parent function here? X squared, guys. It's just x squared. It's a quadratic. The big hint there is the 2. Yeah, it wasn't even a trick. But my parent function is an x squared. So for x squared, we have our smallest values were -3, -2, -1, 0, 1, 2, and 3. Do you remember that? Okay, and therefore the y values for that, the y values were 9, 4, 1, 0, 1, 4, 9. Those are our values of our parent function. Agreed? Yes? Okay. So now looking at what we're transforming it to, notice here how it has our h is 3 and our k is 2. Our h affects which variable? X, and our k affects our y. So to each one of my x's, what am I doing? It's a liar. So I'm actually adding 3 to each one of my x's. To each one of my y's, what am I doing? I'm adding 2 to each one of them. So to each one of these x's, I add 3 and I end up with 0. Yes. And 1. And 2. And 3. And 4. And 5. And 6. Then to each one of my k's, I'm adding 2. So I have 11, 6, 3, 2, 3, 6, 11. The red values are the values of my transformed parent function. So I go to 0 and I'm going to go where? To 11. So 0 up to 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Remember 10, that this is 11. Bam. I'm going to go to 1 and go to 6. 1, 2, 3, 4, 5, 6. I'm going to go to 2 and go to 3. 1, 2, 3. I'm going to go, where am I at? 3 and go to 0. I'm going to go to 4 and go to 3, 5 and go to 6, and 6 go to 11. And here's up. Well, I thought that's where it was. Pretend that I went through all these points perfectly. And there's my transform function. I shifted to the right 3 and I shifted up 2. No, I did not. And you guys were just going to let me be there. How dare you? No one of you says, Ms. Jones, you can't count. Now you're going to let me be a failure. Shows how much you pay attention to me. Now I've shifted up 2. Thanks, guys, for nothing. All right, what is my domain? Thank you. Negative infinity to positive infinity. All real numbers. The arrows, they go on forever to the left and to the right. What is my range? 2 to infinity. Sounds like only Ricardo is going to be making a hunt on the test.
It doesn't matter if you have to use that bracket.
What do you mean? Yes, you would be counting them off.
Oh,
It has to be a bracket because 2 is included in my range. It is defined at that point.
Okay, what about the,
Infinities are always in parentheses.
no, what about the other one? It doesn't matter.
What do you mean?
Like the emblem?
I'm looking.
Yeah.
I don't know. That's not it. That's not right.
Maybe there's.
There's 10 minutes.
Is there like a pepperoni there?
No, we're ignoring that. All right. Next, compressions and stretches. Okay. So vertical compression and vertical stretch, it's your A variable. Okay. So your A variable, this also affects y. Okay, so it affects your y values. If your a value is between 0 and 1, it is a vertical compression. You're kind of squishing it down vertically. If your a value is greater than 1, then it's a vertical stretch. Okay, the way I think about this is that if you work out less, the wider you get. If you work out more, the thinner you get. Does that make sense? That's how I think about it. All right, and again, it affects which variable? The y, okay? Your vertical compress and stretch affects your y.
Teachers partner in this announcement. We are working on the bell, so if a bell rings and it's not supposed to, let's make sure we stay on schedule. All students still should be in their fifth period class.
Doy. All right, a horizontal compression. If vertical affects your y, then horizontal affects your x. Okay, this affects your x values. And just like before, your x is a liar. You would think you would be multiplying, but you're not multiplying, you're actually, okay? So it looks like it's a times x, right? It's not at all, okay? It's divide, it's a liar. You're actually dividing each one of your x values by that, okay? That is why we write it as a fraction, 1 over a. Because what is a fraction? Fraction is division, correct? All right. Yeah. Now a is a little different. So a, if you're greater than 1, then it's a compression. That's like playing the accordion. You're compressing. And if it's between 0 and 1, it is a stretch. You're stretching out the accordion. You're using less force. I'm forcing it together, relaxing and letting it fall. Force, a lot of force, little force. A lot of force, little force. I'm playing the accordion for you. All right. And again, it affects our x values. Are we ready to see how this plays out? What are you writing down? All right. So here we have y equals a f of x. So here's my function. It's the graph. Pew, 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 pew. And it gives me my x values and my y values for said points. Now, when I look at this graph, and when I look at this equation, which variable is being affected? My f of x, because my a equals 3. So my original f of x is unchanged, but my transformation is that to each one of my y values, I am doing what? Multiplying by 3. Does that make sense? So x, when I look here, my x values are, if I write negative pi over 2, do you see it? I'm writing the order there. So we have negative pi over 2 and 2. We have 0, 0. We have positive pi over 2, and we have negative 2. We have pi, 0, and we have 3 pi over 2 and 2. Do we see where those values came from? Yes, we're good. No one's like, she made it up. So I didn't. All right. So am I changing the x's? No, because it's an a value and a only affects the y. So then therefore my new y values would be 6, 0, negative 6, 0, and 6. Okay, my y values didn't change. So when I come over here to graph this, this one's still 0 because it's 0. At negative pi over 2, I'm now at 6, which would be all the way off the charts, somewhere up there. At 0, 0, I'm still here. At pi over 2, all the way down the chart. At pi 0, still there. And at 2, 6, I would be, at 3 pi over 2, I would be somewhere up here. So notice how my graph would stretch out. Literally. Pretend that again, this is the straightest lines and the most equal graph you've ever seen. But that's how it plays out. But if it's just asking you to find the values, then you would just list out the values as a table or as an ordered pair. I just wanted you to see it get skinty. Was that terrible? So that's how A works. Now let's analyze how B works, okay? So because we're doing B, our X's are gonna stay the same, but each one of our X values, because we have B equals 2, is gonna be divided by 2, because our X is a liar. It looks like multiplication, but it's actually division. And our F of X's are not changing. So our original is negative pi over 2. I skipped 0. I don't know why I keep skipping that first pi. Feels like something I don't want to write. Negative pi, 0. Negative pi over 2, 2. 0, 0. Pi over 2, negative 2. Pi, 0. 3 pi over 2 and 2. All right, so this time my X's are safe, right? My F of X's, my Y's are good to go. But each one of these X's are going to be divided by 2. So I have negative pi divided by 2 is just going to be negative pi over 2. I then have negative pi over 2. So this is negative pi over 2 divided by 2. What do you do when you are dividing within a fraction? You keep, change, flip. So instead of 2 over 1, it becomes 1 over 2, which means you're just multiplying by 1/2, right? So this equals negative pi divided by 2 times 1/2. And what is that? Negative pi over 4. 0, same thing here. So pi over 2 times 1/2 equals pi over 4. This was easy, pi over 2. Last one, we have 3 pi over 2 times pi over 2 equals 3 pi over 4. So the new homes for everybody. So you would have negative pi over 2 would be at 0. You have negative pi over 4, which is right here, would be at 2. You have 0, 0, still there. You have pi over 4 is at negative 2. And you have pi over 2 is at 0. And then you have 3 pi over 4, this guy, is at 2. So your graph is now doing this. So now you're squishing your accordion, you're applying a lot more force. And it's now been squished in. Okay. Do you understand the difference between A and B's roles? Yay, nay, maybe so. Maybe. All right. So last thing is reflection. So reflection about the x-axis. Oh man. So your reflection about the x-axis, this affects your y values. So if you change the signs of your y values, that's a reflection about the x-axis. What that means is that you're taking your y values and they're going from either negative to positive. They're reflecting over the x-axis. Does that make sense? A reflection about the y-axis means that you are, it affects your x values. That means you're taking your x values and you're flipping them over the y-axis. Okay? And then that's the last of it. And on there, you'll find a lovely chart that summarizes all of it for you because I'm so nice. You're welcome, all put together. And that concludes transformations. Huh?